Okay, folks, looking at types of numbers in this video lesson. So the question says, here is a list of numbers 9, 11, 25, 27, 33 and 40. It says part A, from the list of numbers in the list, write down part I, an even number. So an even number ends in a 0, 2, 4, 6 or 8. So it ends in one of these 5 digits. So that'll be the number 40 because that ends in a 0. Obviously, if it's an odd number, okay, conversely, it would end in a 1, 3, 5, 7 or 9. Okay, these are our odd numbers. Next up, part II, a cube number. So a cube number is made by multiplying a number by itself and then by itself again. So for example, 1 cubed is 1 times 1 times 1, which is 1, so 1 is a cube number. 2 cubed is 2 times 2 times 2, which is 8. Okay, is it in our list? No, it's not, so we're going to keep going. Next up, we're going to have 3 cubed, or 3 to the power of 3. Hopefully you're happy, that'll be 3 times 3 times 3, which is 27. That is in our list. Okay, it's that option there. So 27 is a cube number. Next up, it says here are the temperatures in degrees. Okay, I'm guessing yes, Celsius, I think, in Paris at midnight for 1 week. -3, -7, -2, -6, -9, -1, -5. Part B, write down the lowest temperatures. Lowest temperature is the smallest number. That'll be -9 or -9. So the more negative you go, the colder the temperature, and the more positive you go, so the more to the right you go on the number line, okay, the warmer it is, if that makes sense. Okay, so always refer to like a number line. So the more negative you go, the more to the left you go on a number line, the smaller the number, and the more to the right you go on the number line, the bigger, okay, or the larger the number is. Okay, part C, find the square root of 441. So this actually is, yeah, a calculator question, yeah, calculator paper question from an IGCSE example foundation tier. So I'm going to type in the square root button, okay, which is this button here on my calculator. Okay, it's going to look like that. If I plug it in, I get 21. Because 21 squared, or 21 times 21, is 441. Next up, Hassan says the sum of 2 prime numbers is always even. Give an example to show that Hassan is not correct. So a prime number is a number that has explicitly 2 factors, 2 distinct factors, okay, 1 in itself. Now a really common mistake here that my students make every single year, unfortunately, a lot of them think, not every single student here, but most students here, okay, they think 1 is a prime number, 1 is not prime, because 1 has 1 factor, namely 1. So the first 3 prime numbers here are going to be 2, 3, 5, 7, 11, 13, okay, 15, oh sorry, not 15, sorry about that, I apologize, sorry about that, I meant to say 17, sorry, okay, 19, 23, okay, and 29, okay, they're the first year, like X mark, obviously, then it goes 31, 37, 41, 43, then it goes on, guys, okay, so it has 2 distinct factors, so the sum of 2 prime numbers here. So let's take 2 and 3. Now what is 2 add 3? Because obviously the sum means to add. So 2 plus 3, 2 add 3 is 5. 5 is not, okay, an even number. Okay, therefore I've proved or I've disproved Hassan's statement of the sum of any 2 prime numbers is always even. So pick 2 with any odd number, okay, and then add them. So 2 plus 5 makes 7, that's not even. 2 plus 7 makes 9, okay, 2 plus 7 makes 13, 2 plus 13 makes 15, okay. So take the number 2 and add it to any odd number, you will always get an odd number. So 2 plus 2n plus 1 will be in the format 2n plus 3, which is always an odd number. Okay, because 2n plus 1, yeah, is what I call the nth term, okay, of an odd number, and 2n is the nth term of an even number, okay? say. Okay, thank you.